Okay, number one, you don't have to do two, hey? I just copied it from that worksheet. Number one, area squared. I don't know how to do that. 9 squared. Yes, 20 squared, which is 900. Please, guys, I have said this before. I'm just saying again, you have to have your units for this work. Okay, for every single answer, you must always put a unit, please. So whatever it was, I'm going to square it to area. Find number one. There is number three. Okay, let's go to three side. I will just now when I go to the next one. Number three, it was pi radius squared, right? The radius gave us 2.5. Now guys, for this 2.5 squared, you didn't have to put it in brackets. I just prefer when it's like a decimal, I like putting it in brackets before I square it, but it's fine. It doesn't change the answer. Okay, fine. And this one I rounded to 2 decimals. Let me quickly see what the answer was there. Everything all right? So it was pi times 2.5 squared. All right, so that's what I got there. So do we all agree with 9.63 if we're rounding to 2? Okay. This step is actually more important than the first. Okay. Guys, did everyone hear Ryan's questioning? The question was, is it okay if you just write the formula and then the answer? Guys, you should rather actually leave, if you want to leave out one of these two steps, rather leave out the formula, but you have to show the actual substitution. Okay, there you will definitely get a mark for that step. So please make sure that you do show which values you are substituting. No, you don't have to. So guys, in terms of marking, you will get 2 marks for this step. The 1 mark is for using the formula, right? Because I can see what formula you've used here. The second mark is for substituting correctly. If I say you made a mistake, say you put here 5 squared, all right, instead of 2.5 squared. Then you will lose this mark, but then we will see your answer. Okay, so if you don't write that, say you just write the formula and you leave out that little step, and you get the answer wrong, you'll get 0 out of 3. Where if you actually write it, and you made a mistake here, you can get 2 out of 3, or even if your answer is wrong. Okay, so please remember that, guys. Okay, number 1 there, right? And then you can see number 4 as well, guys, at the bottom. That was just the area of a right angle triangle. So half base, which was 3 times perpendicular height, which was 2.5. And you can look at 5, which is next to it as well. That was another triangle, but guys, this is now not a right angle triangle, but they did give us the perpendicular height. Okay, so the base of this whole triangle is 66, the perpendicular height was 14. Any questions? All right, I'm just moving across so that you can see number 6. Guys, in number 6, you could have split your shape up differently. So you could have drawn a line here, right? And then worked with that top rectangle and this bottom one. That's fine. Your answer just needs to be the same. We've got an answer 170. Okay. Yes. Yeah, guys, you didn't have to number them. I just numbered them so that you know what to look at when you're not. Oh, that's right. All right, guys, so here, if we're looking at this rectangle, then we bring the 20 times 6. Okay, for these measurements, let me just zoom in quickly. This first rectangle here, 6 times 20, okay, and then the next one, definitely 10, but you have to figure out what this value is over here. So guys, that whole side was 20, and that top part was 15. So do you see where I got 5 millimeters from? It was the whole part, which is 20, minus that top part, which is 15. Okay, so for my second rectangle, I got 10 times 5. Okay, if you split it up differently, so if you drew a line there, you will have 6 times 15 for your first one, right? If you did this, guys. Then here you would have 6 times 15. And then this one would be 16 times 5. Yes, 16, because it's that 6 plus that 10, hey? To make up that whole side, times this one, which is 5. Okay, just in case you split it up differently. And you would do 6 times 15 plus 16 times 5. Same answer. Okay, great. Okay. Any questions on this one, guys? All right, let's look at the more complicated examples, guys. So it was 7 and 8 on the first two. And guys, this first bit, again, you don't really have to write this down. What's wrong? So this one, that is on. And 9, 3. Okay, I'll look at the wrong one now, please. Oh, wait. Yeah. Okay, guys. All right, guys, let's quickly look at this one. Remember, if you are doing the shaded area, you need to find the area of the whole shape and then minus the white part, right? The part that's been taken off. Yeah. Okay, just hang on, I'm gonna get to that one now, please.
But I that's right.
That's awesome. Okay, so this one, guys, this is a triangle, right? It's not a right angle triangle, but you see they did give us the perpendicular height of that triangle. Even though there's no 90-degree angle there, this is still like the actual height, right? So from the base to that top point. So this 29 centimeters is the perpendicular height. Right? And the 29 here was the base. So for the area of the triangle, it's going to be half times base, which is 29, times perpendicular height, which is also 29. And then you must minus the area of the circle, which they gave us the radius, right? So pi radius squared, pi times 9 squared. Then you just type that into the calculator and you will get your answer. Let me quickly just see in terms of rounding what that answer was. Okay, so it was that 166,030. So guys, if they say it was round to 2 decimals, do we agree with 0.03? Let's say they say to 3 decimals, what would I say? 0, 3, and then 1. Hey, because the next one is a 9. Okay, so just be aware of that. For the next one, this was a square, 16 by 16. All right, so 16 squared minus the area of the circle, pi times 8 squared. I'm also just going to check the rounding for that one quickly. 54,938. All right, so we do have to round that up to a 4. If we did a 10, your answer would be no, but if you did a 10, you're going to negative answer. It's definitely wrong. Okay, if you do a 10, I think then you Okay, so just for future reference, right? If you're getting a negative answer, then maybe you put something. All right, let's look at number 9. So guys, number 9 was quite a difficult one actually. Again, you could have done it 2 different ways. So I'll talk about the other one where you could have split it up like this, right? That's also fine. We'll just have different values. So guys, I decided to split it like that. Does anyone else split it up like I did? No. Okay, very few people. Okay, I'll show you the other way just now. So guys, if you split it up like that, then we have one long rectangle here. Hey, do we agree with 14 and 4? Where did I get this 4 from? The whole length is 11. Right, do we agree with that? And then they told us that that is 7. So 11 minus 7 is going to give you 4. Okay, that's where that 4 came from. Let me just zoom in a bit. So this 4 was from 11 minus 7. Okay, so that area there is 14 times 4. Yes? Now guys, for these two rectangles, and at the most they are two separate rectangles, do you agree that they have the same length of 7? Both of these, right? But now guys, how do you figure out what that length is and that length? Yeah. Mhm. Okay, so I see what you're saying, right? But they didn't act, so it looks like they're the same length, these two. But did they actually tell us that they are? No. Okay. So you will get the same answer in the end. You do get the same answer. But obviously now, what I did here was I realized I don't really know how to find that length on its own and that length on its own. They didn't actually give us enough information. All right, so you could have, and I think that's probably what most of you guys did. So we agree that the length of these two parts together must be 7. So there's 14, right? And then that middle part is 7 meters. So if you take the 14 and you take away that middle part, then that will give you those two lengths together, right? Which is 7. But now, guys, you actually can't just divide it by 2 because they do tell us that these two parts are equal. Okay, even though it kind of looks like they are, all right, but they probably were, but we couldn't actually say that they were. So now what you had to do was you had to visualize that you are putting these two rectangles together as one rectangle. Can we try and do that? Imagine, imagine we take this rectangle and that rectangle, we put them together as one, like this. Right? Those are those two rectangles that we put together as one. What is this length here? 7 meters. Oh, it actually turns out to be straight. And then this part and that part together should also be 7 meters. Sorry, so my picture isn't correct. It actually ends up as a square. All right, so these two, let me show you. This square, basically, that I've created here, actually consists of these two rectangles put together. Right? Okay, Oren, you have it up first, yes? Nine, 7 times 7 makes it 9. Yeah, all right. And I think that was like for all you would lose wrong. So your answer would be correct, but it would be correct with an incorrect working. Yeah. 7 times 11, but I think didn't you split yours up like this? Yeah. And you also got the same answer. Yeah. Okay, guys, so like I said, if you did 7 times 3.5 plus 7 times 3.5, you get to the same answer, but you will lose a mark there for assuming that those two parts are equal. Okay, or what Anna was suggesting now, which I didn't even think of, and that takes away this whole thing, is you can do this calculation. Right, the big rectangle here. What would this area be of the whole rectangle? 14 times 11 minus the white part, which is 7 times 7. Yeah, that's actually quicker. All right, so let's add that. I'm going to say here, area of big rectangle minus area. Guys, there's a lot of chatting, please. We need to focus. Minus area of square, so that's going to be 14. And Aaron, you got to the same answer, hey? Yeah, okay. Minus 7 times 7, and that gives us 105. Yeah, we find it out on that. That one was a bit tricky, but yeah, hopefully, okay.
That's why I don't.
No, we see this only just started, Alright, what is this now? Okay. Okay, thank you. Number 10, guys, there, 180. You asked for that answer? Okay, great. 180 squared. Cool. So it's like a house, right? But it's actually a square plus a triangle. So the square there is 12 squared plus, looking at the triangle, of base, which is 12, times perpendicular height, which is 6. Okay, next one, 11. So, well, guys, you can see the next one there next to it. You can mark 11 so long. Alright, a big square minus a small square, right? So 6 squared minus 3 squared for that one. 27 centimeters squared. Alright, number 12, last one. Please go up. Yeah. Alright, again another half shape, right? The same as number 10, it's just drawn in a different like orientation. And now also guys, this bottom part of the half is not a square like in the previous one, right? It's a rectangle, 20 times 15. And then this one is a triangle with a base of 20 and a perpendicular height of 10. Yeah. Oh, so your answer, okay. 220. All right, when you guys are done marking that, please make a new heading. We are starting a new chapter. Number patterns. Okay, thank you. Okay, now guys, we are going to come back to that worksheet again, all right, in the next few weeks. We do have to do those other questions and mark them before your test, which is on the 23rd, which feels like it's very far, but I think it's like 3 weeks. Hey, let's quickly check what day is that. The 23rd. next term 5. So the 23rd is a Friday. Is that not gonna do public holiday?
Yes, no, I don't do it.
No, the 24th is saying. It's better to get out. I'm gonna have to get back to you guys because the 24th is Heritage Day, which is on Saturday, so surely then we get the Friday off.
Yes, no, yes.
Let's go because the Heritage Day will be on Friday. I said, okay, I'll just check. No one's actually said anything about it. But anyway, it's this week, this Friday in 2 weeks. Alright, so it's basically 3 weeks time. Well, that's it. Okay, guys, patterns. We are going to jump straight in by looking at let me do this heading. Describe and extend patterns. That will be the first heading. All right. So I'm going to write an example here of a number pattern. So if we have 2 and then we have 8, and guys, usually with number patterns, we separate the terms using a semicolon, not just a comma, because a comma can also be a decimal comma. All right, so let's use a semicolon always. So we have 2 and then 8 and then 14 and then 20, and then I'm going to do another semicolon. And then I'm going to do another semicolon and 3 dots. What does that mean if I put 3 dots in? It's carrying on, right? So 20 is not the last number in that number pattern. It can still carry on. Yes or no? So, you mean a comma and nothing? So a comma can just be a decimal comma as well. So maybe if I write 2 and then a comma and an 8, it might look like 2 commas. 2.8. Okay, so rather use a semicolon to show that it's separate numbers in the pattern. So guys, going forward, I don't want us to refer to these numbers as numbers in the number pattern. The actual proper name for them is actually terms. Alright, so terms in a number pattern. So for example, 2 is term 1. Okay, I'm going to write here, just leave like 2 lines open. I'm going to write term 1 is 2. But guys, to make it even shorter, because we want to write term a million times, we're going to do it like this. T, and then we're going to put 1 as a subscript. So T1 like that, instead of term 1. Okay, the next term 2. So the next number, the second number is term 2. That's 8, right? So we can write term 2 with the word. You're more than welcome to write it out like that if you want. But to save time in a test or exam, we can also just say T2 like that, right? With the 2 as a subscript. All right, term 3, next one. But we can write that as T3 as well. Term 3. But guys, what do I do in this number pattern? Don't chop it off. I know some of you obviously recognize it already. But what am I doing to go from term 1 to term 2? Don't chop it off. And then the same thing must happen to go from term 2 to term 3. And then the same thing from term 3 to term 4. Okay? I'm adding 6. Okay, do you guys see that? So guys, the way that we usually indicate that is we do a little like a little thing, like a little loop. Plus 6. We just write underneath. And then a plus 6 again. And then another plus 6. So guys, that plus 6, that number that we're adding every time, right? Only if it's the same number every time, we call that a constant difference. Okay, so we're going to say here, the constant difference is 6. And also a constant difference is a very long, well, 2 long words to write, so we can actually just say that D is equal to 6. Right? D is the symbol that we use for the constant difference. Guys, if I ask you to describe this pattern, alright, then you need to understand that someone that is not seeing this list needs to be able to look at your description and write that number pattern down. Okay? So what are we going to say? How can I describe this number pattern? Yeah? Constant difference. Yes, good. So we have to say that the constant difference is 6, right? But then guys, you also have to tell me what number to start at. Because if I just say it's a number pattern with a constant difference of 6, I might say, okay, the first number is 1, alright? But you might say, let's make the first number 5, alright? Someone else might say, let's make the first number 10, right? And then add 6 every time. So when you are describing a pattern, we're going to write here, describe. Oh, nothing. Describe. A nice little tune. The first number, but guys, what did I say now? What word did I use for the first number? Term. The first number or term, thank you, is 2. And now you can also say this in 2 different ways. You can say, and the constant guys. What a chaotic lesson. And the constant difference is 6, or you can say, if you don't want to write constant difference, you can also say the first term is 2 and you add 6. Right? So instead of saying the constant difference is 6, you can also just say you add 6. And the marker will understand what that. But guys, if they ask me to extend this number pattern, what am I going to do? Keep adding 6, right? Add 6 every time. Alright, so let's say extend to the 6th term. But guys, how many terms do we have currently? 4. So the same with extend to the 6th term, we need to write down the 5th term and then the next one. Alright, so now again, you can decide how you want to do this. You can basically list them. So what would the next term be? If my 4th term is 20, what's 20 plus 6? 26. And then the next one, I was add 6 again. What's that? 32. Right, so you can just list them like that, or you can write term 5 is 26 and term 6 is 32. Now, which is obviously a bit longer, but some people might like actually writing them off systematically. Okay, but both is fine, guys. Now, what if they ask you for the nth term? Nth term. NTH. Fine. How am I going to write this? N write down an expression for the n term like that. So that will be the letter N. Just gonna explain it. All right, for the n term, guys, it's in a number. No, right? N is a variable, right? A letter, we call those variables. And guys, what they're actually asking now is basically they're asking for a formula or a rule that will allow you to find the value of any number, any term in this number pattern. So guys, instead of a specific number, right, a specific term, like term 5, term 6, term 10, we need to find term n. All right, so I'm going to write here the n term is the same as term n, like that. And then also ask you for the Cn, the fourth Cn, same thing. And guys, this is a general formula or rule, if you want to call it that. That will allow you to find the value of any, and I'm putting that in all caps because that is important, of any term in the pattern. Because guys, if I ask you for term 5, it's very easy, right? You just add 6. If I ask you for term 6, again, you just add 6. If I even ask you for term 10, you just keep adding 6 a couple more times, right? But what if I ask you for term 300? Does anyone want to add 300 times? No, right? So that is why we need an actual formula that will allow us to find the 300 term. But guys, we have actually done this before, just in a different way. We remember flow diagram. We have given you the input value and the output value, you must find the rule. That's exactly what we're doing here. Okay, so we're going to draw a flow diagram for this number pattern that we have with these four. And guys, quickly, this is term 1, right? We agree with this? The first number is term 1. So the input value for this one is going to be 1. I can now focus and we're going to answer questions and I'm not going to answer them. This number here is term 1. The output value is 2. The input value is going to be 1 because it's the first term. This one is going to have an input value of 2 because it's the second term. And what's the output value going to be? The actual term, eh? 8. All right, so I'm going to do it like that. Let's do our little block. And we're going to have 1, 2, 3, and 4. Guys, come on. Thing is working against me. Okay, let's just try sort this out quickly. Maybe if I do my bottom of the page. There we go. Thanks. Okay, so 1, 2, 3, 4. Because we have 4 terms. You have not been this irritating. Yeah. Okay, the output values were the actual values in the number pattern. 2 and 8 and 14 and 20. So 2, 8, 14, 20, like that. And guys, even in term 1, we were able to find this rule. And you remember we did this in term 1. What did you do that time? You checked, hey? You checked. Okay, yeah, I'm adding 6. Yeah, I'm adding 6. Yeah, I'm adding 6 again. Do you guys remember that? We did exactly this thing up here, right? We just had the numbers actually listed and we saw that there was a difference of 6. Can anyone remember what we did different than 6 in the rule? Yeah. So, yeah. We multiply by 6, okay? Does that sound familiar? And what are we going to multiply by 6? Guys, if you're asking for the nth term, what variable do you think we have to work with? N, okay? So we're going to have a 6n. All right, now. Okay, so you find your constant difference, that number you multiply by n when they're asking for the nth term. Guys, what if they ask for the nth term, right? A different letter, then you'll multiply by that letter. Okay, so whatever this variable is, you multiply. But guys, let's quickly see. For n, my input value, what is 6 times 1? 6. Is that what I want? I want 2, hey? So what must I still do if I have 6? I must still minus 4. Let's see if that works with my other numbers as well. What is 6 times 2? 12 minus 4, will that give me 8? Yes. What about the next one? What's 6 times 3? 18 minus 4 is that 14. Alright? So guys, Tn for this one is 6n minus 4. I'm going to write down now underneath this step by step how we got that. Because guys, you don't want to write, you don't want to draw a flow diagram every time. Okay, that's going to take very long. So let's quickly think, what did we actually do? We checked for the constant difference. Okay, so that's your first step. So step 1 is find D, which is a constant difference, right? We know that D is a constant difference. Step 2 is multiply n by D, by that constant difference. We're going to do a whole bunch more examples now. So you find the constant difference, then you multiply n by that constant difference. Okay, and our example here was 6. So 6n. And then for the third step, you need to look at what is missing. What do you still need to do in order to get your first term? Okay, so now I'm going to say, check what needs to be added or subtracted to get the first term. And then the last step, which you just kind of do in your head, is just to check that your formula works for the other numbers as well. Okay, so check that formula works for the other terms. And if they've given you like 10 terms, you don't have to check all 10. You can just check like 1 or 2. Okay, and just make sure that it does work. If it worked for the first 2 or 3, then it won't work for the rest. Oh, the section. In rule test on the 23rd. Depends on what we actually get through. Yeah. All I know is it's not me. I don't know. It's still in a while, so it hasn't been set yet, so I haven't been able to check. All right, guys, let's try a few more examples. Thank you. Without having a flow diagram, just with a list of numbers. Okay, because that's how it will be asked in a paper exam. All right, so I'm gonna write here examples. All right, thank you. The whole class doesn't have to be involved in your history. All right, number one. Thank you. What is going on today? Okay, that is the first one. 3, 7, 11, and 15. And guys, for these questions, you don't actually have to show any working, all right? The only working that you show basically is finding what you're adding or subtracting every time. We'll do one just now where you're subtracting. So what do I do to go from 3 to 7? Plus 4, hey? And just from 7 to 11? Plus 4 again. And from 11 to 15? Plus 4 again. So what is my D value? My constant difference is 4, all right? So guys, I want you to write, we'll just do it on the side to save some space. Tn is going to be 4n, hey? So that's your first step, guys. So that's actually the first two steps combined. Finding your constant difference is this step here. And then just doing constant difference times n. All right, that is your second step. Now you need to check, guys, what term is 3? Term number 1. Okay, so I'm just going to write it above here. This is T1. So what would my input value be for that one? What is the input value for term 1? 1. All right. So what do I do if I say 4 times my input value times 1? That is 4. What is my first term though, guys? It's not 4, hey, it's 3. So what must I do to 4 to get 3? Then minus 1. Yeah, and that's it. That is your general formula, your rule. Yes. I'm not going to give a mark for a trial. Now let's see if that works for the other ones as well, guys. What term is 7? 7 is term 2. So my input value there is 2. What is 4 times 2? It's 8 minus 1 is 7. Okay, so it does work. All right, let's do another one. I don't even gonna have to think here about this. All right, guys. My first term here is 4. The second term is 1. Do we notice that it's getting smaller now? We're actually minusing. Hey, what am I minusing? 3. From 1 to negative 2, I'm minusing 3 as well. Hey, from negative 2 to negative 5, I'm also minusing 3. So guys, the constant difference now is negative 3. Okay, you can't say that it's 3. It's negative 3. So here for your Tn, you're going to have negative 3n. Whatever number you had there. In the previous one, it was positive 4. So it was 4 times n. Now it's negative 3. So it has to be negative 3 times n. Okay, now let's see. I'm going to add the subtract still to actually get my first term. So 4 is my first term, right? My input value there is 1. What is negative 3 times 1? Negative 3. But I need to get to 4. So what does I do to go from negative 3 to 4? Plus 7, eh? Yes. Yes. All right, for the next one, let's just check that it works with my next term as well. Term 2. So my input value there is 2, right? What's negative 3 times 2? Negative 3 times 2? Negative 6. Plus 7 is 1. Okay, so it does work. All right, I'm going to do one more with you guys. Number 3. Um, 34, 38, 42, 46, dot, dot, dot. What am I adding, guys? 4 again. Plus 4. Is it the same? 38 plus 4 does give you 42, right? And then 42 plus 4, yes, that is 42. Okay, so Tn is going to be, how am I going to start? What do I do with my constant difference? I multiply by n. So 4n. Now guys, for term 1, what is 4 times 1? 4, but I need 34, so what does I still add? 30. So 4n plus 30. For term 2, let's see if it works for term 2. What's 4 times 2? 8 plus 30 is 38, and that is my second term. Okay. Right, that is what you guys are going to practice for homework. All right, so exercise 4.5. And guys, this is all you have to write for these types of questions. You will get a mark for the 4n and a mark for the -1. Possibly a mark for showing this +4. All right? Sometimes they will give a mark, sometimes not. It depends on who's taking the question. So this is either 2 or 3 mark question. All right, so you don't have to write all of them extra stuff. We're basically just looking for the answer for these. Okay, so exercise 4.5, it's on page 49 of your textbook. There are 5 number classes there that you have to find the rule for, the end term. All right, so in the heading it says something about use equations to describe, I don't know what they mean there. So all I actually want you is to find Tn. Okay, so exactly like what we did now, that's all you're doing. Tn is equal to what? Okay, there are 5 number classes there. All right, you can pack up, guys. On a physical copy. So yes, send me an email today, but bring it tomorrow.